Let's take a look at how to elevate with powerup. Here I am in Cobalt Strike with a system beaconing back every 5 seconds. If we do a whoami/groups, you will see that J Smith here is a nobody user on this system. We are not a local administrator. Okay? So what I'm going to do to try to elevate is bring in powerup, which is under the Power Tools folder. And we're going to run invoke all checks. Okay? And think of powerup as a privilege escalation vulnerability scanner. And I know I said that a moment ago, but can't be said enough. So this script is looking for different things we might be able to use to elevate, okay? So one of the things that looks most interesting to me is this vulnerable service. It looks like the Adobe ARM service is configured with weak permissions that allows me, as an anybody user, to update that service and make it run whatever I want. And if I can make a service run my executable, well, then I'm system. So what we're going to do is change the configuration of the service to point to an executable of our choice. Let's go to a folder that we know we can write to. So users J Smith. And let's go ahead and export a service executable. And what we're going to export is a stageless SMB beacon. And I did that kind of fast, but if you go to Text, Packages, Windows Executable S, that's your option to get a stageless SMB beacon. Let's output this as a Windows Service Executable, press Generate, and we'll call it evil-adobe.exe. Now, let's go ahead and upload that file to the target. And let's use the sc command to reconfigure that service. So let's do scconfig, Adobe ARM service, bin path equals, c:users, J Smith, evil-adobe.exe. Let's do sc stop, Adobe ARM service, in case it's already running, and sc start, Adobe ARM service. And at this point, our beacon should be running in memory on the target. Now to assume control of it, we'll just do link 127.0.0.1. And if all went well with our attack, we will establish link to a child beacon that is running a system. We didn't even need to worry about how to egress. So that's how to use powerup with Cobalt Strike's beacon. Okay. By this point, presumably, we're elevated. Let's talk about how to recover credentials and hashes with Beacon, okay? Beacon does integrate Mimikatz. If you type logon passwords in the Beacon console, this is like a Mimikatz meta command that will run several credential harvesting techniques. It will pull hashes for domain users, and in Windows 7 environments, it will also pull plain text credentials in some cases as well. You can use hash dump to recover password hashes for local accounts on that system. The hash dump command in Beacon works by injecting into LSASS. Do keep that in mind. There's a mild amount of risk with that. Small, but the risk is still there. Both of these commands will automatically populate Cobalt Strike's credential data model. If you go to View, Credentials, you can see the credentials recovered with these commands. Okay, let's take a look at hash dump and logon passwords. If you go to View, Credentials, this is where credentials brought into the data model will show up. Let's just do access, dump hashes, and there we go. There's the password hashes for the local account. And let's come over here and do access, run Mimikatz. And Mimikatz will work to recover the plain text passwords of any users who interactively logged on since last reboot, or any creds that are in memory. And there's J. Smith's password, plus the password hash of any domain accounts as well. So that's Mimikatz. Same information goes into the cred model as well. Now let's take a moment to focus on Mimikatz for a second. A lot of folks associate Mimikatz as just a way to recover credentials on a Windows system. Mimikatz is really much more than that, okay? Mimikatz is a full-on post-exploitation tool set for advanced persistence. It gives you tools to harvest trust material, meaning credentials, hashes, and Kerberos tickets. And it also gives you tools to repurpose that trust material so you can interact with services with that material you recovered. You can run an arbitrary Mimikatz command in Beacon by just typing Mimikatz, the command you want to run, and its arguments, okay? That will pass the command to Mimikatz's command dispatcher and provide the output back to you. You can also do Mimikatz exclamation point command arguments, and Mimikatz will elevate to system and run the specified command for you as well. With both hashdump and Mimikatz, Beacon is smart enough to recognize if you're on a 32-bit or a 64-bit system and to deploy the right version of Mimikatz or hashdump for you. Here are a few Mimikatz commands I'd like you to be aware of. There's a lot more. This is just meant to be a sample, okay? You can use the LSA dump cache command to dump cache credentials. That's something you would normally use a Metasploit Framework post module for, but Mimikatz has a command to do it as well. LSA dump SAM is very similar to hashdump. It'll recover user account password hashes. misc : command will re-enable the command shell if it's disabled in the registry. That's pretty cool. misc : memSSP will patch LSASS to automatically log credentials after a user authenticates to that system. And those credentials are stored in C Windows System32, mimi-lsa.log. It's pretty funny. misc : skeleton is pretty neat. This command patches LSASS to make it so that the Mimikatz password works for all users on the domain. That's pretty wild stuff. Very much an advanced threat tactic. You can also use the process module to suspend a process. Just do process : suspend PID. And that's a way to stop a process from working without actually killing it. And you can do process : resume to resume a process. And that's just a very small sample of what Mimikatz can do. Okay, let's take a look at some of the other things that Mimikatz can do. Let's interact with this beacon that is running as system. Let's do Mimikatz LSA dump :cache. And this is the command to recover cached credentials of domain users who have logged on to this box. Now you can't use these cached credentials to pass the hash, but you can try to crack them. So the main purpose of these credentials is to allow users to log on to the system even if it can't reach the domain controller. So that's the dumped cached credentials option. Let's take a look at memSSP, which is kind of cool. It's a neat little credential harvesting thing. So let's do Mimikatz misc : memSSP. And Mimikatz will come back and say injected. That's cool. Now let's see if I can do something that causes a user to log in. Running paint as administrator should do the trick. Now let's go find the file with the credentials. This is a 64-bit system. So let's go to sysnative, because that's C Windows System 32. And let's look for mimi-lsa lsa.log. Whoops, not like that though. The clear command will clear the beacon command queue in case you make a mistake. Okay, let's look for mimi lsa.log. And there it is. Let's just use the type command to put it up on screen. And there we go. There's the credentials for the administrator user who logged on since we patched the memSSP or installed the memory security provider. One thing to note, you are putting this file on the file system, and that's bad tradecraft. I certainly wouldn't recommend this particular tactic in production, but it'd be great for an exercise. Okay, so in this lecture, we talked about privilege escalation and a few privileged actions with Beacon. I introduced you to user account control. I took you through the privilege escalation options in Beacon. We talked about powerup. I took you through basic credential and hash harvesting, and we talked about how to use Mimikatz in Beacon. This concludes Part 5 of Advanced Threat Tactics.